Good afternoon. Today we are going to learn the RLC circuit, which can moderate as a second order differential equations. Okay, for example, this RLC circuit with R equal to 20 ohms, L equal to 5 Henry, C equal to 10 to the power of negative 2 farads. ET is 100. In the initial condition T0, Q equal to 0, I equal to 0. So, we want to model it, in terms of charge, current I first, followed by the charge Q. So, to solve the current I, so we have this RLC circuit. VL plus VR plus VC equal to ET. So VL is L VI VT, VR is IR, VC 1 over C integral I dt equal to ET. To eliminate the integral, we have the ddt both hand side, so we ddt L di dt plus R is constant, you can factor out, and then ddt I plus 1 over C ddt integral I dt equal to ddt dt. So L is a constant, you may factor out, so you have L ddt di dt, so L d2I dt2. So ddt I, we have R di dt. Okay, ddt integral I dt, you get I, so over C equal to d phi t. So this is the RLC circuit. We have seen in the previous two lectures. We have the RC circuit. Once we have here with RC, we have only R di dt plus I over C equal to E prime t. So it's first order. Now with the inductor, we have the L d2I dt2. Okay, now we can plug in the RLC and the ET value. Okay, R is 20, L is 5, then here 5 d2I dt2, okay, R is 20, so di dt, okay, this is plus, I is 10 to the power of negative 2, ET is constant value 100, so differentiate 100, we have 0. We get this is a second order homogeneous equation. Okay, divide by 5, we get 4 di dt. So 10 to the power of negative 2 is actually, bring up is 100 divided by 5, we have 20, I equal to 0. Then to find the second order homogeneous equation, you may let the second derivative by your m squared, first derivative by m. Okay, I is actually m power 0 or 1. Then you may find the roots easily using, if you can factor, you may factor. Here, if possible, is either you use your quadratic formula, or you may use a scientific calculator. Whereas the coefficients here, key in the coefficient for your equations. Choose polynomial equal to, key in the coefficient for your quadratic equation 1, 4, 20. So the root negative 2 plus 4i, negative 2 minus 4i. Means the m you have negative 2 plus minus 4i. Okay, which is in the form of alpha plus minus beta I, and refer back to that table for homogeneous solution. Your I should be in the form of, you have exponent alpha t, a cos beta t plus b sin beta t. This is the third case of we have the complex root where the alpha is a real root. In this case is negative 2. So exponent negative 2t. Okay. Beta is a positive value of your imaginary root, which is 4. So a cos 4t plus b sin 4t. So this is the general solution. So you notice for second order you have two integral constants. For first order differential equation we have one integral constant. Now we plug in the initial condition in order to get your particular solution. T0 I equal to 0. You say have 0, and then you have, because exponent 0 is 1, cos 0 is 1, sin 0 equal to 0. That's why I have here 1 multiply a, b here is 0. So 1a equal to 0 means your a equal to 0. Okay, how to get the t? Remember you have another initial condition t0 q equal to 0, but here in terms of I. So you can go back to our RLC scale here. BL plus BR plus BC equal to ET. Okay, BC, we have another forms of formula which is actually Q over C. Q over C. So we have a BL plus BR plus BC equal to 0. BL is L di dt. If BR is IR, BC we may have another form which is Q over C equal to 0. Q over C equal to 0. Okay, now L is actually 20. L is 5, R is 20. So this we have I di dt plus 20i equal to plus Q over 10 to the power negative 2 equal to 0. So here di dt plus 4i plus 100q equal to 0. Plug in L is 5, R is 20, C is 10 to the power negative 2. We divide both hand side by 5, we arrive at di dt plus 4i plus 100q equal to 0. Okay, now plug in when t 0, q is 0, I is 0. Okay, that's why you get di dt. Okay, this is 4 times 0 plus 100 times 0 equal to 0. And when t 0, your di dt equal to 0. Okay. So now, from the I, so now we got di dt equal to 0. After we plug in q equal to 0, conjugate from here, you already know a is 0. So, okay, plug in a equal to 0. So I is actually exponent negative 2t b sin 4t. And now we want to find di dt. Because when plug in T0, Q0, we know dIdt equal to 0. So now we need to find the dIdt. DIdt, this is in the form of U V. Product form, this is U, this is V. So your dIdt, we have U V prime plus V U prime. So U, which is exponent negative 2t, U differentiate to V, which is 4B cos 4t, plus a V, which is B sin 4t. Differentiates the U, we have negative 2 exponent negative 2t. Now we plug in T0, dIdt equal to 0. We have 0. So exponent 0 here we have 1. Cos 0 is 1. So 4b. Sin 0 we have 0. So 0. Oh, and now what's the mistake? VL plus VR plus VC equal to ET. What was the mistake here? Because we couldn't get A0, B0 at the same time. This is ET. ET is given 100. So ET is 100. So 100. So divide 5 dIdt. So this one is 100. Divide by 5. So this will be 20. So when T0, dIdt is not 0 but is 20. So there's a mistake here. Because VL plus VC equal to ET. So 100 divided by 5, 20. So when T0, I0, Q0, dIdt you get 20. So T0 dIdt is 20. So this is 20. Therefore, B equal to 5. So plug in B equal to 5, you get I equal to 5 from here. B is 5. So I is 5 exponent negative 2t sin 40. 5 exponent negative 2t sin 40, which is the particular solution. So it obtains a particular solution. From this RLC circuit, because the ET is 100, E prime T is 0, we have the second order homogeneous equation, which is the complex root. So we get I is exponent negative 2t multiply A cos 40 plus B sin 40. This is a general solution. And then when you plug in T0, I0, we found A equal to 0. When I reduce to I equal to exponent negative 2t B sin 40. To solve for B, we need to use the second initial condition, which is when T0, Q equals 0. So, but here is in terms of I. That's why we have to, and we know VC is actually Q over C. That's why we plug in here. When T0, the I is 0, Q is 0, we find we know that dIdt is 20. So to get dIdt from the I, you differentiate respect to T. Here you have to use a product rule. Then plug in T0 dIdt equal to 20. We found B is 5. Plug in 5, you get this is a particular solution. So we have solved for the first one, model the RLC circuit in terms of current I. Now we would like to model in terms of charge Q. So against the same RLC circuit, we have the VL plus VR plus VC equal to ET. If we want to solve in terms of charge Q, so BC is a motion scale Q over C. So VL, we have L dI dt. VR is IR. VC is Q over C. So equal to ED. Okay, and we know okay, I is actually rate of change of charge. I is dq dt. So I here plug in by dq dt, and then di dt will be d2q dt2. So L di dt become d2q dt2. So I is dq dt. So Q over C equal to ED. So you compare, okay, if you solve in terms of charge, L d2q dt2 plus R d2 dt plus Q over C equal to ED. But if you solve in terms of current I, we have L d2I dt2 R d dt plus I over C. But this is E prime T. With charge, okay, all the I will change to Q, but this is ED, yeah? Because the VC formula in terms of I is 1 over C integrate I dt. To eliminate integral, we have the ddt. So that's why there's a slightly difference here. And now plug in L is 5. So L is 5, so I have 5 d2q dt2. R is 20, dq dt. R is 20. And then C is 10 to the power of negative 2. ET is 100. ET is 100. Then divide both sides by 5. So dtq dt2 plus 4 dq dt. Okay, this is 100 divided by 5, which is 20q equal to 20. And then now we have a second order non-homogeneous equation. So first of all, we solve the homogeneous equation. Solve the homogeneous equation. So homogeneous equation where the right hand side equal to 0. We have q double prime plus 4q prime plus 20q equal to 0. So this one, then you get the characteristic equation by substitute second derivative by m squared, first derivative by m, and then q is m power 0. Okay, as just now we obtain the same m, or the same characteristic equation where the m is negative 2 plus minus 4i. So, okay. Negative 2 plus the same characteristic equation. Negative 2 plus minus 4i. Hence the q, this q for homogeneous is a complementary function in that qc. Exactly, you have exponent negative 2t a cos 4t plus b sin 4t. QC is similar to the I, okay, just now, because when you're solving for current I, you have only homogeneous equation. That's why we didn't have the IC, because it's only homogeneous. But here we have got homogeneous and non-homogeneous. So QC is a homogeneous solution. Exponent negative 2t a cos 4t plus b sin 2t. And then now we have the non-homogeneous part. This one means this is the FT. The FT is 20. So I'm going to choose a QT, the particular same form with your FT, which is constant, so AB, it's K. So you check K here, not collection. Constant, this is product of exponential with cos and sin. So totally not clash. Hence Differentiates. Because here you have first derivative, second derivative. In Q, we are going to substitute by K. So we have dq dt. So differentiate K constant, we got 0. So differentiate K second derivative also 0. Okay. So you plug in all these things into the second order non-homogeneous equation we have here. So 20k, after you plug in this result, 20k equal to 20, means the k equal to 1. The k equal to 1. For this case, the QP is actually 1. Q particular is equal to 1. And the general solution for the Q is actually your QC plus QP. It's a QC plus QP. So where the QC is actually exponent negative 2t A cos 4t plus B sin 4t, then plus 1. So this is a general solution. As I said, general solution you must have for second order 2 integral constant, for first order 1 integral constant. Okay, now to get the particular solution, okay, you may plug in, you have T0, Q equal to 0. Okay, that's why we have here 0, exponent 0, this is 1, cos 0 is 1, sin 0 is 0, so that's why you get here A equal negative 1. Cos this one 0, cos, okay, this is 1, this is 1, so that 0 equal to, this one is 1, this one, so A plus 1, so A equal to negative 1. And then split to reach to find the B. Then we have another one when T0, I equal to 0. Okay, I is actually dq dt. So we have I is actually dq dt. And here, after A is negative 1, we plug in. Your Q is actually exponent negative 2t, negative plus A negative 1, negative cos 4t plus B sin 4t plus 1. It now finds dq dt from here. So again, you need to use your product rule to differentiate. This is U, this is V. So your dq dt, we have U V prime plus V U prime. So U, okay, down U is exponent negative 2t. V prime differentiates here, differentiate cos negative and negative positive, so 4 sin 4t. Cos negative 4 times negative, so positive 4 sin 4t. Differentiate sin positive, so 4t cos 4t. Differentiate 1, 0. Okay, plug in dq dt equal to I. So when t0, I equal to 0. So 0, this is 1, exponent 0 is 1, sin 0, 0, cos 0 equal to 1. So we have 4t. So t equal 0. Oh, because I haven't finished differentiates, no wonder. Okay, the mistake is this is only U V prime plus V. V is here. Negative cos 4t plus B sin 40 multiply u prime, differentiate this, negative 2 exponent negative 2t. So now plug in cos 0 is 1, so plus negative 1, sin 0, is 0, sin 0 is 0. Okay. So multiply exponent 0 is 1, so this is negative 2. So 0 equal to 4b plus 2. So 4b equal negative 2. b will be negative half. So b is negative half. So plug in a is negative 1. A negative 1 already plug in. So b is negative half. You get the particular solution. Where the q is exponent negative 2t. A we already plug in negative 1 here. So negative cos 4t, b is negative half, sin 4t plus 1. Then now we have obtained the Q already. We can double check because we have the same RLC circuit. RLC circuit initially we already modeled in terms of I, and we obtained the I. I that we obtained. I is 5 exponent negative 2t sin 4t. So to check whether our Q is correct, we can do actually, we know I is actually equal to dq dt. So we are going to check whether the dq dt here will obtain same with the I that we obtained in the first part of the equation. So dq dt. So again, we have Q. This is Q. This is here. Q. B prime, differentiate your B. So positive 4 sin 4t. Differentiate this one. So we have negative 2 cos 4t. And then plus b, negative cos 4t minus half sin 4t. Differentiate the u, which is negative 2 exponent negative 2t. Differentiate 1 is 0. We check whether the I, after we simplify, can get equal to the current I that we obtained in part 1. Okay. So 4 sin 4t, this one sin 4t. Negative 2 times negative half, so means positive 1 sin 4t. So total negative 2t for sin, we have 5 sin 4t. We got 5 sin 4t. Okay, this is negative 2 cos 4t. Okay, negative and negative. This is positive. Okay, this term, this one, this one. This one when plug in, this is 2 times cos 4t exponent negative 2t. Okay. This is tally with the particular solution of part 1, which is exponent negative 5 exponent negative 2t sin 4t. 5 exponent negative 2t sin 4t. Because the same RLC circuit. The same RLC circuit is modeled in terms of charge current I. we have L d2i dt2 plus R di dt plus I over C equal to E prime t. Because Et is constant, E prime t we have 0, which is second order homogeneous equation. We solve the second order homogeneous equations. Then here, plug in T0, I0, we manage to found A equal to 0. To get the P, we plug in T0, Q0. However, we see we change in terms of Q over C. And then when T0, given T0, Q0, I0, we get the IDT equal to 20. So to get the IDT from the I that we obtain, after we plug in A equals 0, we still left P. So we found the IDT and then plug in T0, the IDT equal to 20 to obtain the P. After obtain the P, we get particular solution for the current I, which is 5 exponent negative 2t sin 4t. The same RLC circuit, it will model as in terms of charge Q. So VC is Q over C, I is dq dt, didt over d2q dt2, et is K100. So you get second order non-homogeneous equation. To solve second order non-homogeneous equation, you have to solve homogeneous equation first. That's why the Q, C, you have the same pattern with the I, because I is only homogeneous equations. And then we solve the non-homogeneous equation using undetermined of coefficient, where the Ft is constant. So we choose Qp is also constant, and we have to check whether Qp is clashed with the Qc. So this is constant, this is the product of exponential and cos or sin, so it's probably not clashed. Hence, this is safe to be used as a Qp. So Qp we will plug in as K. So dq dt means you differentiate K, you have 0, differentiate second time is 0, that's why 20k equal to 20k equal to 1. Hence the general solution for your Q will be Qc plus Qp. To get the particular solution, we need to plug in T0, Q0, then we manage to solve A is negative 1. So we still need to solve for the P. For P, as we know, I is dq dt. Hence for Q here, we need to use product rule to differentiate K in order to find for the P. Just now the mistake, I just find Q P prime but forgot to find P prime. So after plug in T0, I is exactly dq dt equal to 0. We found P is negative half. So plug in, we get this one is actually particular solution for your charge Q. This is particular solution. And to check whether our particular solution correct or not, we know I is actually equal to dt. That's why using scale differentiation of product rules again, and simplify it, we get dt which is I, which is 5 times exponent negative 2t sin 4t, which is valid with particular solution of I that we obtained in part 1. With this case, thank you for your attention.